Welcome to the 7th International Multidisciplinary Conference on Current Research Trend IMCCRT 2023. My research topic is Design and Implementation of Intelligent Refrigerator. Presenter myself, MD Saidur Rahman, Senior Lecturer, Department of Tripoli, European University of Bangladesh. Introduction. An intelligent refrigerator is one which possesses self-monitoring capability of food item or material with minimal or no human intervention. The intelligent refrigerator will help the consumer with the entire chain of duties involved in supply or stock of food, food freshness, and food nutrition awareness. Like my technology, main goal of intelligent refrigerator is to improve quality of living of people. Here showing the architecture of the system of my research. We are mainly discuss about the pH sensor, color sensors, force sensor, contact sensor, and temperature sensor. And both outputs are combined Arduino. Arduino's outputs are showing on display GSM module, SMS, the subscriber identification module, Android app, GPS, tracker, finding storage, voice notification in different language, text notification in different language, Yandex Translate, Google GTS, and voice search. Architecture of the system. The proposed prototype on intelligent refrigerator has a refrigerator unit with 3 separate compartments of meat, vegetables, and fish. pH sensors are used to determine whether or not a product is rotating in a monitoring solution. Detection of color change is detected by a color sensor, which compares it to the stored color and delivers an alert. Force sensor is measured the Newton when a weight is added to the force sensitive resistor sensor mounted on the Arduino. The user will be alerted if the weight falls below a predetermined threshold. A temperature sensor near the compressed unit has found that there is a risk of fire or overheating in the refrigerator unit. A contact sensor is also put on the door to make sure it is closed. The user should be alerted when a product freshness or a stock status changes. The GSM modem receives a signal from the Arduino if a stock is low or not fresh. Messages like your meat or fish is not fresh or your supply is low will be sent to the user's cell phone through GSM modem. If we don't have a smartphone, this is a great alternative for us. Sending a control message to a GSM modem results in an SMS to the user's cell phone. Then Android users will receive both the text and voice notification if our companion application is installed. If the user selects for example, Bangla as their preferred language, the subsequent message will be in Bangla. The user has the option of receiving video feeds on both their mobile device and computer. The customer is on the lookout for a nearby retailer. Simulation and result. The result was processed with the collecting data and the response of the different circuit simulation and also from different circuit implementation. Our main target was to collect the data from some specific circuit and analyze the output result. The output result helps us to have a realization of basic idea about the intelligent refrigerator technology and the basic architecture. Also, these results help to map the future of the technology and drawback, limitations, and necessary development of needed. Then we discuss about the force sensor. Force sensor, the result was processed with the collecting data and response of different circuit simulation and also from the different circuit implementation. Our main target was to collect data from some specific circuit and analyze the output result. The output result helps us to have a realize of the basic idea about the intelligent refrigerator. Here we are showing the figure force sensor during experiment. Weight of salt was measured. Result came as 10 Newton for 1 kg. 10 Newton is equivalent to 1 kg. on kilogram. Here showing the force sensor setup. Then we are discuss about the pH sensor. The pH level of the water was measured and the average value of 7.19, where the actual pH value is 7 for water. The extra value of 0.19 was counted as an error. This sensor works for both room temperature and also for refrigerator temperature, such as 4.0 degrees centigrade. Here showing the output data of pH sensors. Here the three main points: liquid name, exact pH value, and experimental value of pH. We are measuring the actual value and experimental value of water, milk, and mango juice. Here showing the table: water exact pH value is 7 and experimental value 7.19, where 0.19 was counted as error. Milk exact pH value is 6.40 and experimental value is 6.37. Mango juice is pH sensor is exact pH value is 4.40 and experimental value is 4.60. Here showing the real picture where when we are measuring the fresh milk and where we are measuring the pH value of fresh milk and when it is turned stale. pH was measured for milk when it was freshly brought from a shop. pH was 6.37. Next, a morning pH was measured when it was turned stale. Measured pH was 4.34. Then we are discuss about the color sensor. Here we showing the real value of an experimental picture of color sensor when we are measuring meat freshness. Color was measured for meat when it was fresh brought from shop. Then the meat was kept and refrigerated for 1 day and allowed to turn stale. Then color was measured again. Result is tabulated below. Here we are showing the result, experimental result and fresh and ideal result. When fresh, when red is fresh and stale. Showing the 4 colors: red, green, blue, and we are observing the time. Red is on 45, and when the when the meat color is changes, then it turned stale. Green 95, and when it is stale, its value is 92. When for the measuring the blue, fresh value is 100 and stale value is 95. Color sensor. When meat was fresh, it was reddish, but it turned a bit darker red when it turned stale. That was a human eye observation. Result from color sensor matched observed color change. While green and blue remain almost same, but red changed from 145 to 125. Also, color was measured at room temperature and also is freeze temperature, varying distance between color sensor and test object. The result of the color sensor was obtained in 2 steps. At room temperature, the object was first assessed: red 25, green 20 to 55, and blue 128, where the anticipated outcomes based on the readings of red 245, green to 219, and blue on 134. The color was then once more measured while the color sensor was still inside the refrigerator. A table with the outcome is provided. We utilized Microsoft Paint to examine what those principles stand for. Steps on and 2 resulted in a close or occasionally exact match of the colors. However, it was found the measurement recorded at a color temperature shifted for more quickly the reading take at normal temperature. Here showing the color sensor output and showing the 4 cases of data table. Color sensor result for the different color with the comparing original color. Additional flawless color was produced when the item was a specific distance away. However, our course was done in such a way that at freeze temperature 4 degrees Celsius more result was taken. Result is shown in the table left. From the case 2 to 5, the freeze temperature was same, but distance between color sensor and the object was varied. We wanted to see how variation of distance between color sensor and the object affected output. Then we discuss about the temperature sensor. Temperature of a compressor unit of a working freeze was measured and monitored for an hour. Also, temperature of room was measured to compare. Temperature of the room at day of doing experiment was 26.37 degrees Celsius and compressor unit was 37.11 degrees Celsius. 45 degrees Celsius is the threshold above which the user gets notification about passable overheating. Then we are discuss about the GSM module, global system monitoring. The GSM module successfully transmitted and receiving SMS to the user's mobile device. If the user doesn't have smartphone, it is their primary method of communication with the refrigerator. Here showing the picture GSM module setup and SMS notification. When freshness or stock information is changed, the user needs to receive a notification for that matter. Arduino receives information from sensor, and if a stock is running low or not fresh, Arduino will send input to the GSM modem. GSM module will send SMS to users' mobile phones, and SMS is very specific. For example, your meat or fish is not fresh or your stock is running low. This is helpful for users who don't own a smartphone. If the user has a smartphone, or a companion app will take it from there. Android app and user interface. User interface design or UI of the application app is kept simplistic and user-friendly so that most people can interact. Here we are showing the Android app user interface figure. There is 5 buttons and a text label. First button finds nearest stores. It uses built-in global positioning system GPS sensor of a smartphone to get latitude and longitude address of user's current position and using GPS and Google Maps to find nearest stores. Here is the advantage or benefits of our project, of our research. It will make life easier, flexible, and consumer will be aware of the stock of food and be conscious about their food freshness, nutrition, etc. Real-time and continuous monitoring through an IP camera. The consumer will be notified through mobile phone about food stock, sale information, and hazard situation about nearest shop location where the consumer can buy products. A free Android compatible mobile application comes with the system for user interfacing which is easy and user friendly. Voice recognition, command, and several language support have been facilitated as well. System may come integrated or it can be brought separately and installed. Any refrigerator can be turned into intelligent refrigerator. Easily customizable and to suit users' needs, user can add or subtract any feature. Low cost and easy to replaceable. The proposed smart refrigerator can enable better nutrition and health. Limitation and future one. Here we are showing the limitation of research and how to develop in future. Despite the fact the numerous smart freeze concepts have received a lot of attention and effort, there are still some glaring short outcomes. The following examples are provided. The technology is too complicated for the majority of home users who require a more user-friendly interface. For individuals who have little to no computer knowledge, there is a meager network connection either because there isn't adequate support or it isn't a high-speed connection. Later on, this topic may incorporate a variety of functions with the beneficial functionality. Other fundamental and more sophisticated criteria can also be used, as only a few of the primary criteria for an intelligent refrigerator have been illustrated in this study. Here we showing the moreover there are other approaches to build this project in future. Notification of when to clean the fridge due to bacteria accumulation, power management of load shedding, food nutrition features can be added, which can be used for monitoring how much different kinds of nutrition such as carbohydrate, protein, fat are available in the stock, food in the stock in refrigerator. The whole circuit can be designed in a different way, which will make the whole device faster than before. Here is the conclusion of our research work. The proposed smart refrigerator can enable better lifestyle and health. Although the design is implemented for managing household fridge items, but the system can be implemented for superstores and groceries as well as with the slight modifications. Depending on the user's need, options and facilities can be enabled for generating groceries leads and receipts depending on the stock. Store managers can keep an instant eye on inventory. The characteristics, functions, and design details of the smart fridge are presented in detail. However, with market research, customer needs, and industrial support may help this project to come to life became important part of consumer life. Thank you everyone to hearing me. Allah Hafiz.